Morning, guys. So here is our second lab. Let me show you again how to open an R file into RStudio. Okay, so I'm gonna send you the R code and also the handout for lab 2. So first of all, you need to right-click the R file, right? And then you open with RStudio. Make sure you uploaded your RStudio because I just uploaded myself. Okay, here it is. So basically, I haven't started too wrong. So you see the environment is empty and there's no plots here and also no output here. Okay, so let's start. Okay, so this is our lab 2 simple regression model covered the chapter 1.2. Okay, so today we're gonna run your first regression with LM function. So the goal of this lab, first of all, you should be learn the LM function. Okay, this is the tool for running regressions, and learn how to read summary model output. And then we're gonna manually verify that R's formulas match what we derived in class, okay, from chapter 1.2, the OLS estimator and also R squared. Next one, practice interpreting slope coefficients in real examples. So basically, right, how to manually calculate the OLS estimator, the R square, and also how to interpret. Those questions are in the mock exam as well. Okay, so here I want to show you and let you practice on your own. Okay, get familiar with it. So before this lab, you should already know from our lecture, chapter 1.2, the simple regression model. Okay, so here we're talking about the simple regression model, which means one x and one y. So here y equal beta 0 plus beta 1x plus mu. Next one, the OLS estimator, okay, which I showed you on the practice exam. Beta 1 hat equal SXY over SXX. Okay, next one, R squared, which means the share of variation in Y expanded by X. Next one, let me emphasize how to use this script. All right, so for each line, if you want to run it, you click on a line or you highlight several lines, and then you press Control plus Enter for Windows, CMD plus Enter for Mac, to run that line, okay? Or you put your mouse here and then you click the run. Okay, next one. Part 0. We need to load packages and data, right? We need to call for that. So we load the package, we installed it in lab 1. Okay, so if you get an error, there is no package called blah, blah, blah. So you run install package first if you get the error, okay? So this is our lab 1, all right? We need to install the package first, and then we call it. Since I just followed from my lab 1, basically I already installed this package, which is Woodbridge, so I don't need to install it anymore. But if you got an error, you need to install it first. Okay, so here I'm gonna use library to call the package. Boop, boop. Okay, no error, so let's continue. We have some warning message. They said that this package was built under R version 4.5.3. But don't worry, this is a warning message. And actually, my R version is 4.6 something. Okay, so you need to check. If your R version is lower than this one, you need to update. Okay, next one. We're gonna load the wage dataset again, okay? It's about wages and education for 526 people. So we use this one to call. And you see here, okay, in the environment, we called the dataset and we quick reminder of what's inside, okay? We use head, which, you see, this is the example that we use in the textbook. Wage, education, experience, tenure, blah, blah, blah. Here are so many X, right? But today we're going to use simple linear regression, which means 1X. Okay, part 1. I told you before we run any regression, always check your data, okay? Visually check means we need to plot them. Always plot your data before running a regression. This helps us see the relationship and catch anything weird, such like the outliers, nonlinear patterns, before trusting a formula. Okay, so we're going to use this function, plot, right? So this, let me try to run it. Okay, you see here the plot. The main means the title here, x-axis, year of education, y-axis, okay, hourly wage. This may be the line type, and this is the color, right? And you see this plot. Does it look like a straight line? Which means linear relationship. It's rough, right? But there's a clear upward trend. It means more education, more wage on average. That's what we are about to measure. Next one. So this is our first regression with LM function. LM stands for linear model. This one line runs the entire OLS estimation from chapter 1.2. It finds beta 0 hat and beta 1 hat that minimize the sum of squared residuals automatically. Okay? So the syntax is LM Y tilde X. Be careful about their positions. Okay, Y tilde X and then your data. Read the tilde as expanded by. So here, Y expanded by X. So here in our example is wage expanded by education. Okay, so let's try. This is our Y, this is X, this is our data set. Okay, so let's run it. Okay, so now you see the environment here, model 1, list of 12. Model 1 here, this code now stores everything about this regression, coefficients, residuals, fitted values, stand errors, R-square, etc. Just type in the object name and it shows the bare coefficients. Okay, let's type and run it. Okay, you see here, basically we call this LM function and this is our coefficient, intercept and education. So this is our beta 0 hat, this is our beta 1 hat. Next one, part 3, reading summary model, okay, the full regression table. Summary function unpacks the model object into the full table you are used to seeing in the textbook and maybe in Stata Excel output. And also the R output, okay, from our homework and also the practice exam. So let's run it. Summary model 1. Okay, so model 1 is basically this object. And then we run this. You see here, A lot of information here, right? So let's continue. How to read this output? Basically, match it to our chapter 1.2 concepts. So let's see. Coefficients table, which is here. Intercept. This is our beta 0 hat. Education. For this row, this is our beta 1 hat, which is the slope term, right? The next one, the estimate. This column basically is the coefficient value itself. Next one, the stand error. Okay, this column. This is the stand error. Remember, uncertainty around that estimate. Next one, t-value column. So basically, which is the t-ratio, we use estimated over the stand error. It's useful for the t-test. Okay, so how we get this t-value? You use this one over this one, right? You just plug in numbers. Please practice for it because you have to do this one. And next one, this column, probability, which means it's bigger than the t absolute value, okay, the absolute value of t. So basically, this is our p-value, okay, which means is this coefficient statistically different from 0? And next one, multiple r squared, where is it? It's here. Okay, so you see the multiple r squared, which is 0.1648. So this is the r squared from class, the share of variation in wage explained by education. And here, residual standard error. So basically here is the typical size of a residual, which is the prediction error. You see, this is the significance codes, all right? 10%, 5%, 1%, but we even have 0.01 and also 0. But just use what you learned from textbook, okay? Because the significance level here is more strict. Next part. Extract specific pieces from the model, okay? So here I showed you if we use the summary function, we're gonna get all the information from this model. But sometimes, okay, sometimes you don't always want the whole table. So R lets us pull out individual pieces using these functions. The first one, if you use coefficient, coef, okay, this is the model one. So this, let me run it. Okay, see here. This is just the coefficient, which is beta 0 hat and beta 1 hat. And if you use this one, this means the intercept, which is beta 0 hat alone. And if you use 2, this is our beta 1 hat alone. Next one, fitted model, the predicted wage, which is y hat for every person. Okay, for every person, let me show you. Basically, okay, this is our y hat for every person. Next, mu hat for every person as well. Let me run it. Okay, this is our mu hat for each observation. All right, for each observation. Okay, so the sanity check. Residuals should average out to almost exactly 0. This is a property of OLS that we learned in class, okay? It's not a coincidence, okay? So here, on average, so we use the mean function. Run this one. Okay, what does this mean? Negative 2 point blah blah minus 16, which means negative 0.00, which is very, very small. Okay, that means on average, okay, our residual close to 0. Okay, next one, part 5, verifying the OLS formula by hand. So basically, you need, in class, I showed you beta 1 hat equal Sxy over Sxx, where Sxy equals sum xi minus x bar. X bar is the average times yi minus y bar. Sxx equals sum xi minus x bar squared. Okay, let me show you. It's here. Okay, you check. I labeled the page number for you, okay? So chapter 1.2, page 25. You see, this is our formula. This is beta 1 hat, exactly this formula, right? And then once you get beta 1 hat, you can get beta 0 hat from this formula. So let's calculate this manually and check it exactly matches what LM gives us. This is the moment where the formula on the whiteboard, basically on my iPad, becomes real numbers. Okay, this is our x, this is our y, and then we get the x bar, which is the average of x and average of y. And then you calculate Sxy and Sxx. So next one, you use beta 1 hat manual. Okay, this formula to get beta 1 hat. And this is beta 0 hat manual, which means we calculate it by our hand instead of getting it from the LM function. All right, and here we compare these two numbers with coefficient model, okay, from a LM function. They should match exactly. Okay, let's try. Oh, okay, I need to run this one. Okay, again. Okay, so let's compare. Okay, so basically, if you compare the coefficient, you see this is intercept beta 0 hat, exactly the same. This is beta 1 hat. They are the same. Next one, part 6, verifying R squared by hand. Okay, so this we need to use still in this slides, but page 18. Okay, here. So from our slides, R squared equal, basically here, SSE over SST equal 1 minus SSR over SST. What is SST? Total sum of squares. Okay, so this is the formula, sum yi minus y bar squared. Okay, this formula. Next one, SSR, the residual sum of squares. Okay, so sum residuals squared. So basically, the mu hat I, and then we squared it. This is our SSR. Okay, so let's calculate SST, SSR, and this is our R square manual, and then run it again. Okay, so let's compare this number to multiple R squared in summary model. So basically, where is it? You need to find the summary model. Here, you run it. Okay, so multiple R squared, and let's compare. So basically, I copied the multiple R square here. All right, so now let's compare. Are they same? Exactly right, just different approximation to how many decimal places. Okay, let me zoom out. Okay, it comes back. Next one, interpreting the slope coefficient, which is the most important skill you need to know in this course, okay? The most important skill. We're gonna turn a number into a sentence, okay? So we're gonna let the policymaker or a manager understand. So because we want the slope alone, so we use to call it. Okay, how are you gonna interpret this one? Okay, here I showed you the template. It means that holding everything else fixed. You have to write down this one, otherwise you cannot get the full marks. 1 additional year of education is associated with a beta 1 hat, which is 0.54 increase in hourly wage on average. Okay, so I give you the template here. You need to explain it to me when you do the exam. So try writing this sentence yourself using the actual number you got. Next part, we add a regression line to our plot here. Okay, so this is our scatter plot. Now let's draw the fitted OLS line directly on top of the scatter plot from part 1. The line that LM function calculated for us. So we plot. Okay, so now you see the title changed. Next one, we use abline function, right? And then you see the line. Okay, this is our OLS fitted line. Abline function is smart. It reads the intercept and slope directly from the model object and draw the line for us. That's the end of our lab 2. Okay, so before next class, make sure you can run a regression using LM function, read the coefficients table in summary function, and extract coefficients using coef, fitted, or residuals function. And you need to be able to calculate beta 1 hat and R squared by hand. Next one, you need to interpret our slope coefficient. Okay? So here, after lab practice, modify the code yourself. Okay, so I also show you here in the handout. Okay, after lab practice, the first level, you just change a variable. Okay, you can read this by yourself. Second level, you change the logic, right? Because I told you before, we often use log wage instead of wage. So if you use log wage, how to interpret the beta 1? And next, level 3, which is open-ended thinking, this one is about the R squared, all right? So if you have time, I suggest you practice by yourself, okay? And if you need help, if LM function gives an error, check that Woodbridge and this library are loaded with library function. If a dataset won't load, you run data again before your regression line. If you have any other questions, okay, you can ask me or bring your laptop and come to see me. So that's all for our second lab. I hope you enjoy and good luck for your exam. Bye bye.